11.1, Day 2, Permutations and Combinations. Essential question, please write it down. How do I use combinations to solve problems? A combination is a grouping of items in which order does not matter, whereas yesterday, order did matter. It was a permutation. There are generally fewer ways to select items when order does not matter. For example, there are 6 ways to order 3 items, but they are all the same combination. So when we're dealing with the letters A, B, and C, if order does not matter, there is one way to group A, B, and C. But if order does matter, we could do A, B, C, A, C, B, and so forth. And so then there are more ways to order the items. Here's a formula for combinations, similar to permutations from yesterday. But now we have n factorial over r factorial, and then we're also dividing it by an extra n minus r factorial. Whereas yesterday, the formula was this, which was n factorial over n minus r factorial. When deciding whether to use permutations or combinations, first decide whether order is important. Use a permutation if order matters, and a combination if order does not. Example 1. There are 12 different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? So in this example, order does not matter. It's the way it's worded. He's just drawing a set of 4 cubes from the bag. So if order does not matter, then we use this formula, n factorial over r factorial, n minus r factorial. I know n is always bigger than r, that's 12, and r is 4, because that's what you're selecting. So we have 12 factorial over 4 factorial, and then we have 12 minus 4 factorial. Well, that's just 12 factorial over 4 factorial times 8 factorial. Now let's write this out. So 12 factorial is going to be 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, and 1, all over 4 factorial, which is 4, 3, 2, 1, and 8 factorial, which is 8, 7, 6, 5, 4, 3, 2, 1. As you can see, the 8, 7, 6, 5, 4, 3, 2, 1 is on the top and on the bottom. They're going to cancel. So now what we're left with, which I'm going to write over here, is we're left with 12 times 11 times 10 times 9 all over 4, 3, 2, 1. You can either multiply the top and multiply the bottom and divide, or we can simplify a little more because you can see that 4 times 3 in the bottom is 12, and there's also a 12 on top. Also, 10 divided by 2 is 5. So we can keep simplifying, and what we're left with is we have an 11 and a 5 and a 9. So 11 times 5 times 9 is 495. So Randall has 495 ways that he can draw a set of 4 cubes from the bag. Example 2. The swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? Again, order is not going to matter. They're not giving specific designations like we did in the last video on president, vice president, secretary, first place, second place, third place, coach, player, manager. We're just randomly selecting 2 swimmers from the group of 8. So order does not matter. So we have this formula again, n factorial over r factorial, n minus r factorial. N is 8, r is 2. 8 factorial over 2 factorial, 8 minus 2 factorial. Well, that's just 8 factorial over 2 factorial times 6 factorial. And I'm going to scroll so we can write this out. So now we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1, and then 6 times 5 times 4 times 3 times 2 times 1. As you can see, the 6, 5, 4, 3, 2, 1 cancels with that. And now we're left with 8 times 7 over 2 times 1. Well, we could just go 8 times 7 is 56 over 2, which is 28. Or you could have said, oh, 8 divided by 2 is 4. And again, you're left with 4 times 7, which is 28. It honestly does not matter. If you don't like these extra simplifying that I'm doing, you don't have to do it. I would, though, do this part where you cancel when there's the same set of numbers on the top and the bottom. It's going to make your life so much easier. So there are 28 ways that the swimmers can be selected to swim in the first heat. All right. Example 3. Kate is going to adopt kittens from a litter of 11. How many ways can she choose a group of 3 kittens? Anytime a key word is choose a group, order is not going to matter. They're not specifying an order that they have to pick them in. So order does not matter. So again, we have 11 kittens and we're choosing 3 of them. So n factorial over r factorial, n minus r factorial, which is, and that's going to be 8 factorial. So we have 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1, all over 3, 2, 1, and 8, 7, 6, 5, 4, 3, 2, 1. Cancels, cancels. So now what we're left with is 11, a 10, and a 9, and a 3, and a 2, and a 1. Well, I could go like this right now and say 9 divided by 3, that's 3. And I could say 10 divided by 2, that's 5. And we're left with 11, a 5, and a 3. And 11 times 5 times 3 is 165. There are 165 ways that Katie can choose a group of 3 kittens when order does not matter. If order would have mattered, there would have been many, many more possibilities, or many, many, many more ways to choose the kittens. Another thing I want to write when order does not matter, I should write that is called a combination. And I probably should have done that back on these examples too. That's a combination. And example 2 is a combination when order does not matter. All right. A security code consists of 5 digits. The digits go from 0 to 9, and a digit may not be used more than once. How many possible security codes are there? Well, we have 5 digits. So we have digit 2, 3, 4, 5. Key here is if you have a security code, your order is going to matter, because if you have a garage code on your garage and you go try to type in the wrong code, it will not open. So order is going to matter here. This is going to be a permutation. And with a permutation, we kind of have 2 options. We can use this formula, or we can use the fundamental counting principle. I'm going to do it both ways so you can see both ways. All right. So the digit, another key thing is it says a digit may not be used more than once. So there are 10 digits to choose from. I picked my digit. Now I have only 9 left. Again, I have 8, 7, 6. If it did not say a digit, if it said a digit can be used more than once, or it didn't specify this part at all, then it would have been 10 times 10 times 10 times 10 times 10. But when order matters and it says it may not when order matters, when it says it may not be used more than once, that's why that happens. I picked my digit, it's used. I can't use it again, so now I only have 9 to pick from. I picked that, now I have 8, and so forth. So 10 times 9 times 8 times 7 times 6 is that. That's using the fundamental counting principle. If you would have used the P formula, I would have had, let's see, we have 10 digits to choose from, 0 to 9, and we're picking 5 of them. So we have 10 factorial over 10 minus 5 factorial. That's all we're left with on the top. And look at that. It's just like we ended up with the fundamental counting principle. 10 times 9 times 8 times 7 times 6. There are 30,240 ways to create a 5-digit security code when the digits may not be used more than once. And like I said, when it's a permutation, and it's the reason it's a permutation because it's a code, it's a security code, order is going to matter. Then you can either use the fundamental counting principle or the P formula. You don't have to do it both ways. You'll get the same answer either way. Example 5, we're going to do in class, and example 6, and there are your video questions.